All right, today's January 7th. We are finally getting into multiplying double digit numbers by double digit numbers. This is the first time in fifth grade that we are working officially on multiplication with double digit numbers. Now, you this is a trait, or this is something that you should have learned before fifth grade. You should have learned this in fourth grade. However, how wacky last year was, I'm not expecting that everyone learned this in fourth grade. So this is a very important unit for us, and I think it's also a big weakness in a lot of your guys' math, just the multiplication. But I have a few tricks up my sleeve that I think that we're going to get there. It'll be. I'm very confident that we'll all get to a place where we can multiply double digit numbers with a lot of confidence. I'll get into our challenge questions that you've already completed. A, you knew that you are going to subtract 3/4 from 3 2/5. You turn them both into 20ths because that's the first denominator they both can turn into. And then you also will need to borrow a whole, which turns it into 20/20ths plus 8/20ths. B is a review from lesson 1 of this unit. You get rid of the zeros, multiply 6 times 4, and then put them back on your answer. And then C, I don't know why that 4 is so gargantuan, but that 4 is supposed to be an exponent, so 81 times 10 to the 4th power. And then the challenge question, you are literally just going to tell me if it's more or less than 100 square feet by telling me who is correct. Was Ben correct or was Tina correct? So 10 to the 3rd power, to review, it just means 10 times 10 times 10. The base is 10 because that's that large number that you start with, and that small number is called the exponent. And that's just telling you how many times that 10 is going to multiply by itself. It's not 10 times 3, it's 10 times 10 times 10 3 times. And every year I will get the people that say, all right, what's 10 to the 3rd power? Oh, Mr. Shaw, it's 30. No, it's not 30. It's 10 times 10, which is 100 times 10, which is 1,000. And remember, when you're multiplying by powers of 10, there's a pattern. The exponent will just tell you how many zeros are in the answer. That's the pattern. So to review yet again, 50 is a power of 10 because it ends in a 0, and 60 is a power of 10 because it ends with a 0. You can get rid of those zeros, multiply 5 by 6 to get 30, and then go ahead and throw those zeros back on to see what 50 times 60 is. And that answer is 3,000. All right, so now we have the real question. Why is multiplying double-digit numbers so difficult? Why do we find it so difficult? And the reason is because we multiply with our memory. Okay, we multiply with our memory. That's why your mom always said, you have to learn your facts, right? You have to learn your facts, your multiplication. Or maybe not your mom, maybe it was your teacher, maybe it was somebody, because when you memorize your facts, it helps you with multiplication. Well, that helps us with 1 times 3 and 5 times 6 and 7 times 7 because we can memorize that. But how many numbers can you multiply together in the world? Infinite. So, mom, teacher, whomever you are, when are we allowed to stop memorizing facts? Well, do you know 12 times 12? It's a double digit number. Okay. So that's a lot of facts to remember. 0 through 12. Why do we stop at 12? We don't know. I mean, that's just what we're supposed to memorize. So there's got to be a different way to multiply with double digit numbers, a better method. Because look at, what if you say, oh, I know any number multiplied by 32 up to 22? Well, that's a lot of numbers to memorize. And it's not realistic. You're not going to remember multiplication with just memory alone. So facts are important, right? But we need a method to figure out multiplying double digit numbers so we don't just have to rely on our memory. Here are 6 different methods, so different ways to multiply double-digit numbers, okay? I am really going to just focus on one of those. Looking at these 6 methods, you might have had a 4th grade teacher that taught you one of these methods before, right? So what I normally see from students and even parents are multiplication is just different than it used to be. And that is not true. That is not true because multiplication is multiplication. It's math. It's the same as it has always been. But what we do now is we look at different kinds of ways you can multiply, and we try to find the way that will work the best. So the biggest goal I have for you is out of these 6 methods, I just want you to find one that works. And I don't want you to use your opinion on whether or not it works. I want you to be able to multiply double-digit numbers and get the right answer. So if these methods scare you or freak you out, or you hear your parents say, "Oh, I don't want you to multiply like that because that's not how I learned, or that's not how you're supposed to multiply, or you need to multiply this other way." Me as your 5th grade teacher, I am only concerned with you being able to multiply and get the right answer. So I do not care which of these 6 methods you use. Today, we're going to focus on the area model. But eventually, and we'll talk about the normal method too, which is right here. But eventually, this right here, I found through my 10 years of teaching, this works the best. This works the best, and it's the easiest, and we have the least amount of mistakes. And right now, you're shaking your head because you're like, "No, man, that looks nasty. That's not easy." But you will eventually agree with me. Once your light bulb goes off, you'll be like, "Yeah, you're right. That way is definitely the best and the easiest." I promise you, you will. So today we're working on the area model, it's called. So let me explain to you the area model real quick. Let's look at this blue rectangle. Okay. What is the area of the blue rectangle? Well, the area of the blue rectangle is 15. How do you know that? Because you have to multiply the 2 outer sides. 5 times 3 is 15. So the area is 15. So we can use this idea of area to help us. Let's look at 52 times 35. Well, I just made one box. Pretend it's all the same color. Okay. Pretend you are only seeing all the same color. And instead of it being 52 by 53, why don't we say the top is 50 plus 2 and the side is 30 plus 5, right? Why'd you do that, Mr. Stahl? I did that because we've learned that multiplying, let me use my highlighter here, multiplying by powers of 10 is easy. So I said, if it's 52, let's stop it at 50. And then we'll start a new box at 2. So all I did was I cut it here between 50 and 2. And over here represents 35. So I said, let's cut it here and say 30's up here and 5's down here. Okay. Now, all we have to do is find the area of each box. So this box right here is 50 by 30. 50 by 30, remember the method, 5 times 3 is 15, and then add your zeros. So it's 15 with 2 zeros, 1,500. What about over here? Well, we have a 2 on top and a 30, and 30 times 2 is easy. 30 times 2 is, 30 times 2 is 60. Looks like when I set up the PowerPoint, I did this one next. This one would be 5 by 50. Well, 5 times 5 is 25. Add your 0. And then I probably did this one next up here. You have 30 times 2. And then over here, we have 2 times 5. So if we found all of the individual areas of the broken up numbers, which our memory can do because we all know singles, right? 5 times 2, 5 times 3, 5 times 5, 2 times 5. Then we could put all these together to figure out what the real square was, which will tell us really what 52 times 35 is. So 50 times 30, we put here. 2 times 30, we put here. 5 times 50 we put here, and 2 times 5 we put here. Now, if we add all those up, we get our real answer, 52 times 35. Okay, perfect. Now remember, if this doesn't end up being the method that you love or you feel like you're the most confident with, then you're not going to have to use this once you find a method that you are more confident with. But right now, I ask all my students to try to understand these different methods until you find the one that really works for you. Okay, let's go over and start our work. We are on page 147 to try to make a little bit more sense out of this view, or out of this technique, this method. So it says a flower garden is 67 inches and 43 inches wide. Now, remember, if you like freak out, you're like, oh my gosh, which one's wide, which one's length? I don't know whether to put the 67 on top or the 43 on top. It doesn't matter, because in multiplication, the order does not matter. Okay. Now 67 is bigger than 43, so you put 60 and 7. We turned 67 into two easy numbers. 60 is easy and 7's easy. And then on the side, we have 43. We're going to turn that into two easy numbers. 40 is easy and 3 is easy, right? Now we just have to find the area of each box. So 60 times 40 is 6 times 4 is 24. Add the zeros, it's 2,400. And then 60 times 3, 6 times 3 is 18. Add the zero, it's 180. And then 7 times 4 is 28. And then add the zero from 40, 280. And then 7 times 3 is 21. So now how do we find the answer of 43 times 67? We just add all those areas up, because those areas all together make the big area. So adding them all up, 2,400, 280, 180, 21, and coming up with an answer. So now we know that 43 times 67 is 2,881. Okay. And if you're writing this in your book, I'm cool if you do not put any of this. As long as you, in this box, you put 2,400, that tells me you knew it was 60 times 40, and then here it would be 3 by 60, so just put in your 180. Here would be 7 times 40, so just put your 280, and here's 7 times 3, so put your 21. Add them all together somewhere on the side of your page, and that will give you the total area. Okay, and same thing. I don't care if you don't need to write this stuff. As long as you got that answer, I am a happy person. And it's square inches because we are finding a two-dimensional figure, which we will get into more. But whenever you find area, you put square. All right, let's go to number 2. And if you're feeling confident, pause the video. Okay, pause the video and try this on your own if you're feeling confident. Okay, so 39 times 54. Well, on the top, let's do 54. And remember, if you wanted to do 39 on the top, that's fine. 54. And then on the left, let's do 39. 39. Okay. And then you could be like, Mr. Stahl, that doesn't make any sense. 4, look at the distance of 4. Look how long 4 is, and 9 is shorter than 4. Yeah, they're not when you do this method, it doesn't have to be the real measurement, right? It's just breaking it up into what are those answers. It's not like this one's longer, so it has to be 4, okay? So anyways, let's find the answer. So this is 50 times 3, 30. So ignore the zeros. 5 times 3 is 15. Add the zeros, 1,500. And then we have 50 times 9. Get rid of the 0. 5 times 9 is 45. Add your 0, 450. And then 30 times 4, because it's 4 by 30, 120. And then 9 times 4 is 36. So now we just have to have our answer. Our answer will be, we're adding up each of these, right? We're adding this area, this area, this area, and this area. And our final answer is 2,106. How is this method like the place values sections, method, and how is it different? First of all, that's what I personally don't like about today's math is they throw all these nasty names at people, right? Do we really have to memorize these methods' names? Look at expanded notation method of solving 43 times 67. Look at diagrams A, diagrams B. Look at expanded notation method. Look at diagram B. I mean, did any of you guys fall asleep yet? They make this very difficult to continue to focus on. So let's just kind of talk about the answer for number 3, and then we can kind of forget about this question. But basically what it's saying is, hey, this is one method. You can take 43 and multiply it by 67 by saying 43 is 40 and 3, 67 is 60 and 7. Take 40, multiply it by both 60 and 7. Take 3, multiply it by both 60 and 7, and then find all those answers, and then find the answer. This is this method. They're the same thing. This one just looks nice, and it's easy for our brain to remember how to do every step. This one, our brain has to memorize steps, and I try to stay away from memorizing steps, okay? So if you would like to, just put a big fat smiley face on here, because I don't need you to write down all the fancy schmancy language that they put there. I'm happy with you just saying they're very similar, or put a smiley face, or anything like that. We don't need to get confused by focusing on the different methods and the different names of the methods. We're not going to use this method. I don't really even teach this method. All right, and then we're kind of already close to the end here. So let's look at 4. There are 32 cattle cars on today's train to Detroit. Each car holds 28 cows. So how many cows are on the train? Okay, so this is just, we're going to use, so what you're going to do is, I can't remember, I think they actually give you 2 of these. So you're going to say, okay, let's do 32 on top. So the top would be 30 and 2, and the side would be 20 by 8, because we're multiplying 28 by 32. Right? So try this one on your own and then unpause it and see if you got it right. Here we do 3 times 2 is 6, and then add your zeros, so that's 600. This one is 8. This one right here is 8 by 30, which 8 times 3 is 24. Add your 0. This is 2 by 20. 2 by 20, so that's 40. And this is 8 by 2, which is 16. Now all we have to do is add up all those numbers. So we have 600, 240, 40, 16. This row over here is 6. This row over here is 9. And this row over here is 8. So how many cows are there? Moo! 896 cows. All right. And then Mr. Brooks planning to carpet his office. The office is 21 by 52 feet. We need to figure out the area of the room. So it's 52 and by 21. 50 times 20 is, well, remember, you can get rid of the zeros. 5 times 2 is 10, and then add the zeros. And then 2 times 20 is 40. And then 2 times 1 is 2. And then 50 times 1 is 50. And now add those all together. Well, it's good to line them up, but 50 plus 40 plus 2 is 92. And then 1,092 would be that answer. All right, so to recap, because that is it. That's all she wrote. 5 questions for today. So to recap, these are the 6 strategies that we are going, that are like the common practice strategies for multiplying double-digit numbers. We today worked on the area model, and we're also going to work on the lattice method, and we also talk about your standard algorithm, your long multiplication too. I don't really hit this method. I don't really hit this method, and I don't really well, yeah, we don't really talk about this method for multiplying double-digit numbers. Okay. So let's look at the area mile. This is a representation of 28 times 47. So 20 times 40, get rid of the zeros. 2 times 4 is 8. Add your zeros, it's 800. Down here, this would be 20 by 7. 2 times 7 is 14. Add your 0, and I went in the wrong order again. That would be 140. Over here, it would be 8 times 40. 8 times 4 is 32. Add your 0, it's 320. And then 8 times 7 is 56. And then somewhere in your life on your piece of paper, you would add 800 plus 320 plus 140 plus 56, and you would get the answer of 1,316. All right, and that is all I have for you today, my friends. I hope you're understanding this. I hope you're trying very hard, and because it's mandatory, we have to, before the 5th grade is over, we all have to be phenomenal at multiplying double-digit numbers. And I promise you, if you put in the time, this will be your savior. You will know how to multiply with the lattice method like a ninja, and you will be so proud of yourself. And if you are like, I already know how to multiply double-digit numbers, and I use this method, and I get it right every time, then that is cool too. All right. Happy Thursday, and thanks for doing your work.